Hi, my name is Chris Hawking and my group consists of Kalajera, Z Howard and Zakara, and today we'll be explaining matrices. The topics we will discuss in this presentation is an introduction to matrices, examples of adding, subtracting and multiplying matrices, solving equations using matrices, and using matrices in real-life application. Matrices, or the matrix method, originated all the way back to 2nd century in China and has been modernized over the years to solve simultaneous linear equations, to find unknown variables by transforming the equation into the matrix equation. Now I will discuss the basics of matrices, which is adding and subtracting. So a matrix is defined as an array of any set of numbers. So for example, this a matrix A and B, we have 2 rows and 2 columns. So the dimensions are 2 by 2 and 2 by 2. Now to add these together, A plus B, we need to add the corresponding numbers together to get the final answer. So 1 plus 3 is 4, 2 plus 5 is 7, 3 plus 7 is 10, and 4 plus 9 is 13. Now to subtract A minus B, we use the same principle as before. So 1 minus 3 is negative 2, 2 minus 5 is negative 3, 3 minus 7 is negative 4, and 4 minus 9 is negative 5. Now, if we switch the matrices, so it becomes B minus A, it is the same principle and same outcome as A minus B, just with a positive sign. So the answers are 2, 3, 4, and 5. Now, an important rule to remember when adding and subtracting matrices is that the dimensions have to be the same for it to work. So here we have 2 by 2 matrix and a 2 by 3 matrix. The result of this, of either adding or subtracting, is no solution because the dimensions are not the same. Now, I'll pass it on to Kalajero, who will explain multiplying matrices together.
Hi, my name is Kalajero. I will be showing you the multiplication of matrices. So let's say we have the example C and D. C would be in the dimensions of 2 by 2 and D would be in the dimensions of 2 by 3. Let's say we have an example where we do 2 times C. So what we do is that we times 2 by all the numbers in the matrix. So we will get 4, 8, 12, and 16. If we times the 2 matrices together, the examples of C and D, we had to consider the dimensions first. If the column number of the first matrix does not equal the row number of the second matrix, we cannot, but in this case it does. So when we multiply, we had to consider rows by columns. So what we do is that we do 2 by 1 plus 4 by 4, which will equal 18. And we will do 6 by 1 and 8 by 4, which would give you 38. So we will place the 18 here and the 38. And we apply the same rule for the corresponding numbers of the matrix. So we would get 24, 52, 30, and 60. Let's say we switch C and D around, we got D and C. We cannot solve this as 3 does not equal 2. Therefore, no solution. Now I'll introduce you to Ziha, who will show you how to solve equations with matrices.
Hello, my name is Ziha and I'm here to demonstrate how to solve equation with matrices. This is the inverse matrix. It is 1 over AD minus BC times D, negative B, negative C, and A. To solve this equation, we have to rewrite this whole equation in the form of matrices. So 2, 1, 3, and 2 times x and y gives 32 and 60. Now simply by applying this formula, 1 would never change over AD 2 times 2 minus BC 1 times 3 times D 2, negative B, negative 1, negative C, negative 3, and A, which is 2. Now simplify this equation will become 1 over 1, 2 minus 1 minus 3, and 2. And this will give 2 minus 1 minus 3, and 2. Now to get x and y, simply times by 23 and 60. Using the method that Kalajero mentioned before, multiplication matrices. So 2 times 32 plus negative 1 times 60 gives 4. And negative 3 times 32 plus 2 times 60 is 24. Now, to check this x and y, we can substitute back into the equation. So this will become 2 times 4 plus 24. 2 times 4 gives 8 plus 24 is 32. Right, very solved. Imagine if we have a scenario where a bakery store we need X amount of egg and Y amount of flour to make 32 cakes. Now, with the help of matrices, we can easily calculate what's X and Y. Therefore, it could help the expense management of the business. Now, I would like to let Zach to take over this presentation, and he will explain more about how to apply matrices in real life.
Hello, my name is Zakaria, and I'll be explaining how matrices can be used to solve real-life problems. Matrices provide a unique approach to dealing with real-life problems. Due to their unique nature, they can be used to simplify daily tasks. They can be reconfigured and applied to challenging problems that may arise from business sectors and scientific enigmas. They can be also used to simplify the decision-making process used in large companies. Another use of matrices is in the Google search engines, because having so many data to go through can be difficult. So matrices come in and they speed up the process of the search results by narrowing it down to the keywords used to search problems. Matrices are also of great significance in economics, as they are used to solve many real-life problems, as seen in the previous examples. The applications of matrices were used to find the maximum cost of production, which is an important task to accomplish in the configuration of economic problems in a business sector. Also, an important use of matrices is the ease of the decision-making process in businesses. While making decisions may lean on the ideas and feelings of people, large organizations are in need of a process to focus on the data and run all possible solutions to make an informed decision. That's where the application of matrices are used to enhance the resultant solution. Consider the following example. The applications of matrices were used to compare between all the different locations available to start a company, provide a score of the category in each of their importance, and hence make an informed decision based on the data and facts collected. So if we have a look here, a new manager is trying to start his own business. He has 4 locations to choose from. By applying this, all the like rent, market share, owner contribution, which is the important aspects to the manager, we can use row and column, which is basically the multiplication of the matrix, to come up with the final result. Whichever is the highest result can actually show you that this is the best option to choose. Now I would just like to say that all the examples we used up to here are all leading up to show you how matrices can be used to solve real-life problems. Thank you very much.